All right, we're continuing with square roots, and let's dive right in. What we're going to see is, I think this whole section is on various properties of square roots, and now we're going to use the trick that I showed you in the first videos in this section, but I'm going to show you both. They've got a clever little trick here, which is, so I showed you that if you had the number 50 in there, and you didn't know, so in this case, 50 doesn't have a square root. So what we could do is we could break this down into its pieces. Now, what we're going to see here is that, let me finish this here. Here is what the number 50 is. Now, I began to hint at this before. We're going to be able to take out a pair of fives. So I should say this, a pair of fives allows me to bring out a single five. And what would be left inside the house is a 2. Now this one's pretty easy here, but what they're going to show, so I prefer this because I find most students can't see the trick that they're going to show. But if you can see this, this is much more efficient. Can you see that if you just pulled out a 2, this is a perfect square? So you could find that the square root of 25 is 5, and you could leave the 2 behind. We're doing the exact same thing. I prefer this where you break it down all the way, but they're going to show you that if you could think of this as 50 is 25 and 2 inside of there, and we know the square root of 25 is 5, it can come outside. So, yeah, see, the problem with this is I don't see where they're going to go with that. So I'm gonna break it down the normal way that I like. Yeah, that's what I thought it was going to be. But so what they're saying is this is 16 times 3 in there, but that's not intuitive to me. I don't know all the multiples of 16 easily. So I'm going to show you. So if you saw it like this, you could see that it was 16 and 3. Well, you can bring out a 4 and you'd leave a 3 behind. But again, I'm going to show you my way. So I broke 40 down and I get this, 48 down. Now we're in a square root, so every pair lets me bring out a single one. So I can bring out a 2 from this circle and a 2 from this circle, multiply those back together, I get 4. Now what's new this time is not everything came out of the house. I have a 3 left behind. Okay, now I see where they're going to go with this one, but I don't always. So I'm going to break 45 down. Just do your tree, and you get this. Okay, well, a pair of 3s lets me bring one of them outside. All right, so more of the same here. I'll just show it for the sake of time. It's the same thing over and over again. This one I could kind of see. I see that you could do 5 and 100. 100 is a perfect square. I could bring out the 10. But again, if you didn't see it, you could use my method and you'd get to the same place. All right, so I'm going to break this down. I know where this one is going, but we're going to show it this way. Okay, so there's a lot of numbers here, but you got to break them all the way down to the end. So 288 is, so I'm at the ends of my tree, so my prime numbers are these guys. So 2 times 2 times 2 times 2 times 2 times 3 times 3. Okay, now if you didn't see that you had a perfect square with 144, you can do this. I'm lassoing up all my partners, and I can bring out a 2, another 2, and a 3. So 2 times 2 is 4, 4 times 3 is 12. Now he doesn't partner up, so he's going to stay behind. So I'm slicing this down because it's even numbers. So I'm just going to keep going with 2s until I run out of even numbers. Okay, now I've got 3 and 9. Okay, now if you're clever, you might have found some perfect squares along the way, but I didn't see them. So I'm going to just break this down. the number 432 is made up of all of this. Well, let's circle up the partners. So I can bring out a 2, I can bring out a 2, bring out a 3. Once again, I can bring out a 12, and I leave a 3 behind. Now, the same idea works with variables. So we learned that well, let me show it like this. I think it just would make more sense if you see it like this. You'll be able to see how to do this in your head after a while, but we're square roots, so we can partner up x's and bring 1 out. So what's new in this video is we have 1 left behind. So the same is true for b's. We've got 5 of them in there. Okay, so let's partner them up. Okay, I should lose. Let's circle them. I can bring out a b from this circle, a b from this circle. That's 2 b's. And there's 1 that doesn't partner up, so he stays behind. Okay, now you're going to start to get the hang of this, that you don't need to do it, but I'll do one more where I'm literally going to let's put 9 p's. Okay, so we're partnering them up. All right, so I loop them all up. I can bring 1 for this circle, 2, 3. I can bring out 4 p's, and I've got 1 left behind. Okay, so we've got, now if you have numbers and variables put together, we're just going to do the number. It's 2 problems in one. We're going to do the number, and then we're going to do the letters, the variables. And so I know the square root of 25 is 5. And now you can always write out all the y's, but do you see that you'd be able to bring out you'd be able to partner up 2 of them? So you'd get the 4 of them would make a couple pairs. Do you see what I mean? And then left inside there was 1 that didn't partner up. But if it doesn't make sense, just draw it out. So I'm going to show it because I don't want you to be confused. Okay, that's 5 very terrible looking y's. So we can circle, circle, circle. There's a y left behind. 1 circle, bring out a 5. Bring out 1 y, bring out a second, and there you go. Okay, so if you didn't know the square root of 16, you could do the numbers all the way down. I'm going to be able to bring out a 4, x to the 3rd, square root of x. Now if you don't see that, do the whole house and circle things up. Here, I'd love you to pause it and try it yourself. But this is going to be 7v to the 4th with 1 left over on the inside. So make the house. I got 9 v's in there. Every 2 brings out 1, and this is what you should get. Okay, the only thing that's going to change on this one, I'm going to do it my way. Well, theirs isn't too bad, but okay. Yeah, let's do the whole thing because we got some new stuff here. Okay, so now I've broken everything down, which again, if you can see it with perfect squares, or you don't have to, it's okay. But if you don't see it, this will always get you there. So I can bring out a 2 from this circle, a 3 from this circle. That's a 6. I can bring out an n, an n, an n. I can bring out 3 n's because I had 3 circles. On the inside, I'm left with a 2, and I'm left with 1 more n. Okay, I'm going to just show you the answer here. You could loop it out, but you're going to be able to bring out a 4. That's what you should get. Now you can break it all down, loop it up, but I believe you should get this. Okay, if you're not sure about that, try it yourself, get all the way, but I should get this, 25, yeah, I believe that's right. Okay, the game just continues, the numbers just get more complicated, but it's the same. Let me try one the long way for you where I show you everything. So breaking down 63, we get 3 times 3 times 7. I I got 3 U's in there. I got 5 V's. Okay, let's start lassoing them up. Okay, so I lasso these up. Can bring out a 3, a U, a couple of V's. And the people that don't partner up are the 7, the U, and the V. They can't go out to play, so they are stuck inside. Okay, I'd love it if you try this yourself. I'm trying to do this in my head and see if I can find what would be there. This is what I believe you would get. So again, you can always do the long way. I'm jumping ahead just like I start to be able to do these in my head, but if not, always do the long way. Okay, I don't see, pause it if you want to try it yourself. I don't see what 180 is going to be. Maybe I should. Okay, so if I break down 180, I've got 2 times 2 times 3 times 3 times 5. Now, I'm going to not do all those letters because there's so many of them, but they would partner up. So I'm just going to do the numbers here. So I can bring out a 2 and a 3, multiply that back together and get a 6. Now, if you could partnered up M's, if you partnered up M's, you'd be able to bring out 4. Partnered up N's, you'd be able to bring out 5. And what's left inside the 5 didn't partner, and you've got 1 M left and 1 N. So again, you can write out all those M's and N's and loop them up, and you'll get, hopefully, you should get the same thing as me. Okay, so what they're showing you here is that we can break down this root, but this 3 is going to do basically nothing. We're just going to break this down like we normally would, and there's going to be a 3 that we're adding to it. I think they're leading us to stuff that comes, but they're not like terms. So I break down 32, I get this. But these are different things. The roots are going to work like they're a variable. This is 4, like it was 4x plus 3. They can't be combined. They're not the same thing. So they're not like terms, and that's the best you can do. So if we do the same here, you can pause it if you'd like. Now I just went ahead and did that in my head, but if you do the numbers, you'll get the same. These are not like terms. They cannot be combined. The square root of 3 is like an x. Okay, I'm doing these in my head now, but again, always break them down if you need to. Not like terms, can't be combined. Okay, now this one is going to be interesting. We're going to do the top, and we're going to see, obviously it's 4 minus. They can't be combined, but I'll show you what happens with the 2. So they break that down. They get to this. Okay, just doing the same thing on the top we've been doing. Now, if you're dividing a fraction by 2, if you're making this fraction, you can divide this 2 if, and only if, it's the only way, if the 2 can go into the first part and the second part. If he can go into both, so like you'd see this when we did a circle or on the equation of a line. If you divided both sides by 2, you can turn this into like slope-intercept form, but you have to give the 2 to both of them. So y would divide into the 4 and get a 2, into the 6 and get a 3. So here, I can send this to, well, that's a clever way to show it. They pulled out a GCF, but the way I would think of it is 2 goes into 4 and makes a 2. 2 goes into this 4 and makes a 2. I divided him into both. Now they did the same thing, but I prefer what I've done here. Only if he divides into both parts. Okay, so we're going to break this one down. Now pause it if you want to try yourself. Always got to say that. But I just broke down 75. I get this. Now, the 5 can go into both of these. If he couldn't, I would stop. But he can. 5 can go into 10 and get a 2. 5 can go into 5 and get a 1. Now, it's 1, but I don't really need to show that. So I'm just going to say Like 1 square root of 3, that's just 1. Okay, I'm going to break down the top. I'm going to do this the quick way. Now, if 3 doesn't go into both of these, now they're terms, they're separated by the minus, so it has to go into the first one and there, and it does. Again, this creates a 1 square root of 5. I don't really need the 1. Okay, so now what we've done is we're breaking those roots down, and what we're finding is not everything comes out of the house, but the process is exactly the same.